What other boundaries can we test? Jeff Langer, Andy Hunt, and Dave Thomas, the authors of the Pragmatic Unit Testing in Java 8 with JUnit, wrote this beautiful chapter on other boundaries that we can test. And they call it the correct way. And this is what we are going to explore now. So the first C from correct stands for conformance. And this is about some data element that we receive as an input and that must conform to a specific format. For example, an email always has a name, and then a domain. What happens to a program if you don't provide an email that is valid? For example, an email without a domain. So make sure that you're testing when your inputs are not in conformance with what is expected. Then O is for ordering. The order of data that you receive might influence the output. For example, let's suppose you have a program, and this program receives a list. What happens if this list is already ordered, or if the list is unordered? Maybe this should not influence the results of your algorithm. This means test for it. The next R, range, is about inputs that are usually within a certain range. For example, if you receive age, age should always be greater than 0 and smaller than, let's say, 120. So what happens if you provide numbers that are outside of this range? The book even discusses a very specific topic, which is, in most programming languages, every time you use a basic type, the basic type provides you more than you need. For example, you need to store age, you use an integer, and the integer can store a very large number. So make sure that you're really testing what happens to your input if it's outside of the range. Then the other R is for reference. So when you're testing a method, make sure that all its conditions or constraints are met. For example, if a class depends on a reference that is outside, or an external dependency, or it depends on another object that needs to be in a certain state. So make sure that all these other conditions are met, and if they are not met, your software should not crash. Then E is for existence. Are you sure things really exist? What happens to your software if they don't? For example, if you receive a null as an input, or what happens if you do a query in the database and the database returns nothing? Check how your system behaves when things exist, and more importantly, when they don't exist. Then C is for cardinality, and cardinality is about the famous off by one error. Your algorithm fails because the last iteration of a loop didn't work. You missed one thing to do before you go to the final result. We call it off by one error, or you were almost there. In a way, if we think about loops, a very nice way to see this is what happens to your program if the loop is never executed. Or what happens to your program if the loop is executed more than once, or only once, or what happens if it is executed many times. So this is a way to see how the test looks and the different things that can happen with the loop, because in practice we cannot test every single iteration of a loop, right? Finally, time. And time has two perspectives. The first one, it's ordering in time. What happens to your class if you invoke method A before method B? Or if you just invoke C and you forget to invoke B? Let's suppose there's an order there. Does your system gracefully fail? What should happen in cases that you invoke methods out of ordering time? If you have such constraints in your system, you should test for them. Also, timeouts. What happens with your system if a timeout happens? Timeouts are usually very common things to test in real world because we have latency. Maybe your application is using some 3G connection and this 3G is too slow. Then date time operations. Every time you're doing arithmetic with dates and times, you need to think about it. Are you using the right zone, like UTC or GMT? The book also discusses concurrency, and concurrency is a huge topic by itself, which we are not going to cover right now. These are then the 7 very interesting boundary testing tips from the Pragmatic Unit Testing book. Think about them when really testing and looking for bugs in your system.